So high voltage testing of electrical apparatus. So starting onwards, first we are concentrated on insulating materials, different type of insulated materials, gas type, solid type, liquid type. Okay. Uh, so this is the concept on the first unit, concept. And later that, so we are concentrating on how to generate the high voltages and high currents, and later how to measure the high voltages. Okay, first insulators. We are concentrated on insulators. Second, how to generate the high voltages by using different type of concept, voltage and current. Similarly, so how to measure the high voltages and high currents. Okay, and lighting phenomena. Fourth concept, the last final high voltage testing of electrical operators. Okay, so these are the different types of test. So you know well what is the need of test. Okay, so the testing is compulsory, is required to place the insulators in a particular in a system, in a transmission system. So whatever it may be, in a transmission system or machines also. So compulsory testing is required. Then only it is possible to place. Okay, otherwise we will get some frequent problems if we are not do the test on particular instrument. So frequent problems we are facing on a system. Okay, for example, in missions, if you are not used proper insulation missions, so frequent short circuits may occur in these missions. Right? So the compulsory testing is required of insulations, and then only it is used to place at a particular place. Okay, for example, in transmission system operating with very high voltages. That's why you have to keep it insulators very high voltage withstanding insulators. We have to keep it. Then only the power transmission done without any interruptions. Otherwise, very difficult. Na? So the testing is compulsory. So that is done by in the laboratory. Okay. So the type test to check the design features. Okay, this is the one of the concept to check the design features, and next routine test to check the quality of the individual test piece. Okay, so there are different types of types test and a routine test. Okay, and the high voltage tests include so power frequency test and the impulse test. Okay, so impulse test means just for example, lightning phenomena takes place in a transmission line within the seconds, microseconds or picoseconds. Okay, that can be done. Test can be done by using impulse test. It is also in the range of micro or picoseconds. Okay, same as lightning phenomena. By using this, we have to check the insulator is working properly. Okay, then power frequency test. Okay, tests of insulators and that power frequency test. Okay, so on that dry and west flashover test is one of the concept. So AC voltage power frequency is applied across the insulator and increase it a uniform rate of 2% per second of 75% of estimated test voltage. Okay, by applying the 75% of the estimated test voltage, and we have to increase the uniformly 2% per second like this, up to 75% of the rate. Okay, AC power frequency. If the test is conducted under normal conditions without any rain or dry flashover test. Okay, if the test is conducted under normal condition, rain, wet flashover test. So we have to check this like this man. Okay, dry and wet flashover test we have to check without any rain and dry flashover test. Okay, and at normal conditions, rain and wet flashover test. Okay, so we have to test this insulator is working properly or not with and with and without, and that means without rain, without any rain, dry flashover test, and rain with flashover test. Okay, these two types of conditions are available in atmosphere. No? So that's why the insulators are placed in outside. So that's why you have to check the insulator is working properly or not for these two cases. And dry and with wet withstands test, that is also called as 1 minute test. Okay, the test piece should withstand the specified voltage which is applied under dry or wet conditions. So we have to just test it like this now. The test piece should withstand the specified voltage which is applied under dry or wet conditions. So we have to check like this. Okay. So next, impulse withstand voltage test. Impulse test on insulators. Okay, impulse test on insulators. So the impulse test, very high voltage appear across the insulator. So impulse very less time. Okay, in the fractions of seconds, micro or picoseconds, you know well. So on that time, so we have to apply the very high voltages. So applying that much of voltage, we have to check the insulator is working properly. Okay. So impulse withstand voltage test. If the test object has withstand the subsequent applications of standard impulse voltage, then it is passed to the test. We have to apply the subsequent impulse voltage into the object. Then we have to check this, it can withstand or not. So it is working is okay, then we have to go for another test. Impulse flashover test. Okay, the average value between the 40% and 60% of failure is taken. Okay, the average in generally, so 40% to 60% of failure is taken in the impulse flashover test. Then the insulator surface should not be damaged. By applying the flashover test, also we have to check like this. By applying the average value between the 40 to 50% of the voltage, okay, then we have to check it is a failure or it's withstanding or it's failure of the device, or withstanding the device, or we have to check impulse flashover test. And then pollution testing. So you know well, pollution causes the corrosion. Okay, because of for example, atmosphere, transmission line, porcelain insulator, or that's called pin tabs insulators in substation, suspension type insulators in transmission. They are placed in outside. Okay, that's why you have to check the pollution. So the pollution causes corrosion of the insulating material. Okay, deterioration of the material, partial discharges, and the radio interference test. Salt fog test is done. So these are the different types of tests we have to done on insulators. It's clear. And next, testing of bushings. You know well, transformers. So generally we are using bushings. So what is the need of bushings? So to the bushings are the winding, the current. You have to take the terminals from the outside of the winding, outside of the transformer. Okay, through the bushings. For winding to outside terminals is connected to bushings. Okay, so it is used to isolate the transformer tank to winding. Okay, the bushings. So testing of bushings and the power frequency test. Power factor or voltage test. We have to check the insulator. Testing of bushings and that. So voltage is applied up to this line value in increasing steps and then reduced. Okay, so we have to apply this much of voltage increasing to the transformer bushings and then is working properly or not. And then capacitance and power factor are recorded in each step. Okay, the power factor is also one of the main concepts in transformer. Internal and partial discharge. Just you know well, partial discharge test. I'm already explaining the concept of partial discharge. Okay, because of, for example, in cables, because of watts, the insulation may be damages. So insulation, I mean, the wire size is increasing when the voltage is decreases. Okay, because of that wire, there is a sparks takes place and insulation damages, and the wire size is increasing, and then total complete insulation is failed because of partial discharge. Okay, so initially this partial discharge is not a danger, it's not a severe effect, but is after a certain time, after a few days, so this minor damage, it will become major. Okay, because of partial discharge test in partial discharge in insulator. So that must be take care of the insulators. This is done by using the internal or partial discharge arranged. I'm already explained this concept. Okay. So momentary withstand test at power frequency. Okay, the bushings has to withstand the applied test voltage without flashover. or puncture for 30 seconds. So like this. So these are the standards. Okay, so it can withstand the voltage, that much of voltage up to 30 seconds. Okay, it can it's work properly. So otherwise there is a damage into the system. The bushing has to withstand the applied voltage without flashover or puncture for 30 seconds. Then the device will be called so good. So there is no problem inside of this insulator. Okay, bushings up to 30 seconds. You have to apply the 30 seconds, then it can withstand, then we have to use for practically. If any damages are there, so that is not a good material. So next 1 minute withstand test at power frequency. 1 minute withstand test at power frequency. At power frequency, we have to apply the so voltage for 1 minute, and we have to check the it can withstand the voltage or not. It can okay. The bushings has to withstand the applied test with voltage without flashover or puncture for 1 minute. Here only 30 seconds, but here 1 minute we have to apply. Okay, the bushings can withstand the that much of voltage or not for 1 minute. So that's why it's called 1 minute withstand test at power frequency. And next visible discharge test at power frequency. No discharge should be visible when standard voltage is applied. No, well, standard voltage is applied. When, for example, single phase 230 or 3-phase full for 11 kV, 33 kV. For this, these are the standard voltages. If you are applying the above that voltages, then only it is visible. Okay. So visible discharge test at power frequency. The no discharge should be visible when standard voltage is applied. Okay. And next impulse voltage test on bushings continuation. So full wave withstand test. The bushing is tested either polarity voltage 5 consecutive full wave is applied. If the test object is withstand the subsequent applications withstand applied voltage, then it is passed to the test. Okay. 5 consecutive full wave is applied. So then it can be withstand or not. Based on that, we have to check the insulating material. Chopped wave withstand and switching surge tests. And that it is same as full wave withstand test, but it is done for higher voltages bushings 220 kV to 400 kV. So this voltage is somewhat different compared to full wave withstand. Okay, 220 kV and 4 to 400 kV. So we have to apply this much of voltage to the transformer bushings. And thermal test is also one of the important factors. Thermal temperature test. Okay, in transformers bushings, because of transformer temperature increases when it is operating for full load. Okay, so the transformer heat is dissipated to the atmosphere through the transformer oil. Okay, level. So temperature rise and thermal stability test. So we have to check like this: temperature rise and thermal stability. Temperature rise test is done at temperature below 40 degrees Celsius at a rated power frequency. Okay, the study temperature is rise should not exceed 45 degrees. Okay, in this way, you have to check the temperature, thermal test and bushings. Thermal stability test is done for bushings rated for 132 kV. Okay. Generally, thermal stability test is done for bushings of the transformer at a rated voltage 132 kV and above. So next dielectric test and then impulse test and so testing of isolators and circuit breakers. Okay, isolators and circuit breakers also one of the different above switchgear equipments. Okay, isolator. So isolate the two systems manually. Okay, and circuit breaker is isolate the two system to isolate the healthy system or isolate the faulty system from healthy system. If any fault is occur, then circuit breaker is isolate the faulty system from healthy system. Similarly, isolators circuit breaker also. Okay. So dielectric test that we have to test the dielectric test. The over voltage withstand test, power frequency, lightning and switching impulse voltages. So these are the different types of voltages and then over voltage withstand test of power frequency, lightning and switching impulse voltages. Lightning and switching impulse. These are the voltages are very high. in the range of kilovolts or megavolts also. Okay. So the impulse test and switching suggest test with switching over voltages test are done. So the impulse for isolators and circuit breaker. Impulse test and dielectric test and temperature and mechanical test also done. Okay, on circuit breakers and isolators. Short circuit test also. Okay, direct test and using a short circuit generator as the source, using the power utility system as the source. By taking the two sources, we have to check the circuit breakers and isolators. Okay, by applying externally this much of current or this much of voltage, short circuit current. By using these generators, we have to generate this much of current and we have to check the circuit breakers and isolators operating properly or not. Okay, under dielectric test also. Next, a synthetic test on circuit breakers and isolators. That direct testing on the networks or on the fields, and second one direct testing on the short circuit test and laboratories. Okay, this is done during the period of limited energy consumption or when its electrical energy is diverted to the other sections of the network which is not connected to the circuit under the test. Okay, and direct testing is short circuit test and laboratories. So this is some synthetic test and a circuit breaker test and isolators. So next, so these are the synthetic testing of circuit breakers and the composite testing and unit testing. So these are the different type of concepts under that. Okay, and testing procedure. So this is the testing procedure. The circuit breaker is tested for their breaking capacity. B is called breaking capacity. M is called making capacity. These are the different type of duty cycles we have to find. So B is called breaking capacity. After 3 seconds, so again we have to check the breaking capacity. After 3 seconds, breaking capacity at 10% of the rated symmetrical breaking capacity. So we have to apply 10% of rated symmetrical capacity. For that, we have to check the insulator. For breaking capacity, we have to apply that much of voltage, and then after waiting for 3 seconds, and then we have to check apply breaking capacity of the voltage. At 10% of the rated symmetrical breaking capacity, we have to apply to the insulator. So B, that is called breaking capacity, and 3 seconds after that, we have to apply again breaking capacity voltage. And then so this is the called first one test procedure. Similarly, for applying 30% of the rated symmetrical breaking capacity and 60% of rated symmetrical breaker, first we have to apply 10% of the rated symmetrical capacity. If the insulator is working properly, then go for another test that is called 30% of the rated symmetrical capacity. If the insulator is working for this procedure, and then we have to go for another 60% of the symmetrical breaking capacity. So B, breaking capacity to 3 seconds. Again, we have to apply the breaking capacity through the insulator, and then after 3 seconds and break. So in this way, we have to check the insulator. Okay. So making M is called making capacity. Okay. So the different type of procedures. Okay. Then other one is called asymmetrical test. So here is breaking capacity, and after 3 seconds and making and breaking capacity. After 3 seconds and making breaking capacity and making capacity of the circuit breaker. So 10% of breaking capacity and with recovery voltage not less than 95% of the rated service voltages. So this is the testing procedure. First 10%, by applying 10% symmetrical voltage, they have to check the insulator. After that 30%, after that 60%. If it is insulator is failed here 10%, so we not to do the test. We are not going to test the 30% expense because of 10% is not withstanding means not required to test the 30%. At 10% is failure means that is not the insulator is not working. That is circuit breaker is not properly working properly. If it is success, and then go for 30%. If it is success, then go for 60%. After this, like after that asymmetrical test, one test cycle is repeated for the asymmetrical breaking capacity within the DC component at the instant of content separation is not less than 50% of the AC component. This is some theory about the synthetic test of the circuit breaker and testing of cables. Different tests on cables are first one mechanical test like bending test and dripping and drainage test. Okay, and fire resistance and corrosion test. So because of this is placed under the ground, so that's why this is a mechanical test we have to check. and dripping and drainage test also, and fire resistance and corrosion test also, thermal duty test, dielectric power factor test. Okay, this insulation are three phases. For example, they will separated by insulation. So that's why this dielectric power factor test also is required, and the power frequency with standard voltage test and impulse voltage test and the partial discharge life expectancy test. These are all tests can be done on the insulators and cables. Then you can say that the cable performance. Okay. Now testing of transformers, well, induced voltage tests and a partial discharge test on transformers. Induced overvoltage test. It is tested for overvoltages by exciting the secondary from high frequency AC source 100 to 400 Hz. Okay, to about twice the rated voltage. So induced voltage test is applied at frequency 100 to 400 Hz. And partial discharge test, it is done to assess the discharge magnitudes and radio interference test levels. Okay. The transformer is affected by the radio interference levels or not. So we have to check by using this partial discharge test on transformer. Okay, next testing of transformer, that impulse testing of transformers, and the procedure for impulse testing of transformers and like this. Applying impulse voltage of magnitude 70% of the BIL is nothing but basic insulation level. Okay, so this is one of the very, very important concept, BIL. So abbreviation is also important. BIL means basic insulation level. Okay, so very important concept. Applying impulse voltage magnitude 70%, 75% of the BIL, basic insulation level. Okay, first step, and then one full wave voltage up to 100% of BIL, and two chopped waves of 100% of BIL, basic insulation. One full wave voltage of 100% of BIL, basic insulation. One full wave of 75% of BIL. So, basic insulation level. So this much of voltage waves are applied on this insulator and transformer, and then we have to check impulse testing. Testing of transformer, that detection and location of the faults during the impulse test. So on that the fault in transformer insulation is located in impulse test by one of the following methods. The faults in a transformer can be found by using one of the following general observations, by observing the transformer, any open circuits or any short circuit, any damage by observing the general. So voltage oscillogram method, neutral current method, and transfer surge current method. By using these are the different types of tester, so it can be easily detect the location of the faults in transformer by applying impulse test. Then power frequency spark over test and 100% standard impulse spark over test. These are the different type of tests. Okay, power frequency spark over test and 100% standard impulse spark over test, and then residual voltage test. Okay, so high current impulse test and surge diverters. So these are the different type of concepts, and long duration of impulse test, surge diverters, high current impulse test and surge diverters. So these are the different type of tests. Okay, insulation coordination, last finally insulation coordination. So this is about so 15 minutes.